Yeah. In this chapter, let's look at working with moving averages. What do we mean by moving averages? As the word itself is clear at explaining the term, moving average. Average of the last few periods. That is what we use it as a moving average. So if I say 4 period moving average, it means I am trying to find out the average of the last 4 periods. Or probably if I say 6 period moving average, I am taking the average of the last 6 periods. Why do we need to do that? The simple logic people talk of is, if there is any sudden high value or sudden low value in the data, it can be smoothened out and can be predicted more and more, and the predictions can become more and more realistic. For example, here I look at the share price data. I want to see the 4 period moving average, which is the last 4 quarters average of the share price data. So it's as simple as I'm taking the average of the last 4 periods, and obviously I'll not have anything for the first 3 periods because we don't have the earlier data. So I'll take this to be the last 4 periods average. Similarly, if I want it for last 6 periods, I can very well do it as average of the last 6 periods data. Now, if I try to have a small graph just to understand how this will be helpful for us, what I was thinking is I'll do a small graphical plot of the date, the actual share price, the 4-month moving average as well as 6-month moving average. Okay, let me try to have a small line chart for this. Okay, so this is how the chart is plotted. Right, let me drag the chart slightly to the other side. Now, what are we observing in the chart? The blue line, which is the actual plots, there is some very high value, there is a very steep down. We are finding that the value is not that smooth. In some cases, there is a spike upwards, in some cases, there is a spike downwards, and because of these things, sometimes the predictability becomes a very big concern. And moving average is a very good concept, especially in time series forecasting. This is a time series data because we are talking about the dates at an increasing layer. So this data will fall into the time series category. And what we are observing is in this time series data, forecasting probably for December, instead of December 2012, I have to forecast, let's say, for Jan 2013 or April 2013 kind of quarters based on the past observations. That is where I use the concept of time series forecasting, and one of the important elements which the time series forecasting focuses on is the moving average. So that's where before we get into the forecasting based on time series, we need to understand the underlying concept of that, and that's where I'm looking at moving average concept here. Now, what we are seeing with the 4 period moving average is still there are some spikes in it, whereas the 6 period moving average is looking more and more smooth. Right? It has gone up, then again there was a small fall, gone up. So some kind of a pattern can very well be understood, and predictions can become more and more comfortable if I am using the smoothening of the data using the moving average concept. So that is one of the prime reasons people look at the moving averages, because what we see is if I assume that this is the point where it is the average, the actual value sometimes is more than that, the actual value is lesser than that. What we see is the value is fluctuating around the mean. And from a conceptual standpoint, if I say the green line points to what I call as a signal, what it means is probably that's the green line which I have to use for my estimation or the forecasting purpose. Whereas the blue line, where in some cases I am finding it above the signal line and in some cases below the signal line, is what we call as noise. So we are trying to address the noise by trying to smooth out the signal, by trying to smooth out the data using the moving averages, so that the predictability can become more and more comfortable. And now, once I have got these moving averages and I have computed the 4-period moving average as well as the 6-period moving average. Remember, in this case, we have taken equal weightages. We have done a simple average and we have taken equal weightages. Whereas sometimes people go with different weightages to different periods, which means the latest observation is given more weightage compared to the prior observations. In that case, we call that as weighted moving average. And the way it works is, let's say, I give a slightly different weightages. Probably let me call it as weights. In case of 4-period moving average, let's say I would like to give, instead of 25% weight to all my 4 data elements, I'll give 10% to the old one, then 20% to the slightly newer one, 30% after that, and 40% to the latest. This can very well be given as weightages for the last 4 periods. This is where, so when I compute the 4-period value, what I would simply do is use a kind of sum product function where I take these 4 values multiplied by these 4 weights. So the number I'll take it as 253.75 instead of 256. 256 is more of an equal weighted average to all the 4 observations, whereas when I'm taking 253.75, I'm giving the weights in this proportion. I may give the weights in any kind of a proportion. Once I understand the business and the logic, I can very well give the weights in any of the proportions. So here, depending on whatever we understand on analysis of the past observations of the data, we give some kind of weightages to each of these observations. So in general, what happens is the latest observation receives a higher weightage compared to a slightly older observation, and the very older observations will typically receive very less weightage. As we are seeing in this case, the oldest observation receives only 10% corresponding to the 40% weightage which a newer one gets. So in this way, even the chart may become even more smoothened out with the focus of more value being given to the latest possible observation. Alright. Now keeping this weightages part aside, now the next objective for me is, I have done a 4-period average as well as a 6-period moving average. Now out of these two, which one I should prefer? See, the longer the period is, the smoothening that is happening on the data as we have observed. But that itself could result in some kind of pattern loss. Probably it's a smooth data, that's fine. But it is not, because of the extra smoothness that is happening, it's not capturing some of the desirable patterns in the data. So I have to be slightly careful of in trying to find out which of these averages is more likely to be looked at from my side. So that is what goes with two different scenarios. One is I can go with the concept of mean absolute deviation, which is nothing but arising from the fact that I will check out for which of these 4 period or 6 period, which of these things is actually having less error with respect to the actuals. Right? In this case, probably to make it even more better, when I talk about a 4 period moving average, let me put that formula in the fifth cell rather than in the 4, because if I want to use it for an estimation purpose, I would like to use the 4 period data to estimate for the 5th period. Otherwise, this 256 does not or may not have any kind of a significance. So what I'll do is simply I'll say average of the last 4 values for the 5th one. So everything gets one cell shifted down, and the same logic, even the graph is automatically updated. The same logic I will do in case of 6 period also. I'll do it for the last few periods. So even the smoothing out is slightly getting improved. Now, because I will use this for a forecasting purpose, what I am saying is using the last 4 periods values, I'll try to predict for a 5th period and then compare how much it is better or worse compared to the compared to the actual value. And the selection of whether I should go with a 4 period average or a 6 period average should stem out from the fact that whichever is having the least absolute deviation, I prefer that aspect. So from that standpoint, I am looking at mean absolute deviation. So I'll take the residuals with respect to 4 period and residuals with respect to 6 period. Alright, so let's look at the residuals with respect to 4, and as I said, I'll take only the absolute value. So the actual value is 271 minus the 4 period value is 256. So I am taking the actual absolute values only for all these instances. So with respect to 4 period, my values are something like this. These are my residuals from what was being forecasted to whatever was actuals. These are the differences. Now, if I can take the average of these numbers, that is what will give me the standard mean absolute deviation of the 4 period versus 6 period. And whichever the one is having the least mean absolute deviation, I would be preferring that time period for the smoothing aspect, because it should be very close to reality. Apart from being smooth, it should be very close to the reality also. So that's where I take a simple average of the G column element, saying that the 4 period moving, if I take a 4 period moving average, there is on an average a deviation of 169 units from the actuals, and which I have to check out whether this is the same scenario with a 6 period, or 6 period looks much better compared to a 4 period. Let me try doing the same logic for a 6 period absolute deviation, 6 period residuals. So I am taking the actual value minus the 6 period moving average value. Alright, doing the same scenario again. And in this case, we'll try to find out what is the average of the H column, the residuals of 6 period. 195. So the 6 period residual is actually giving me a very high absolute deviation compared to a 4 period. So in this example, taking a 4-period moving average. Probably I should test out for a 3-period, for a 5-period, all these kind of stuff. But because I have taken the data which is 4 quarters, a 4-period moving average looks more and more appropriate to this data, going with the mean absolute deviation method. Of course, we have quite a few other methods also to look at. But yeah, one of the methods which we can look at is the mean absolute deviation. Now, going with the mean absolute deviation method, we were able to conclude that using a 4-period moving average is much more appropriate compared to the usage of a 6-period moving average in this example. The other scenario, the other mechanism to test out the effectiveness of which moving average to be used, because as we move along into the forecasting aspect, we will see that the moving average plays a very key role in our forecasting element. So, understanding the period of moving average to be taken will play a very critical role in our forecasting process. Alright, so the next thing we will look at is another mechanism apart from mean absolute deviation, which can help us in evaluating which time period or which period moving average is more appropriate. This method is what we call as the least squares method. Now what it simply says is, again, instead of taking simply the average of the residuals, what you do is you find out the square of these residuals and then take their average. Instead of taking an absolute difference, what it says is you take the square of the residual. So each of these things you square and then divide by 24 by the average, whatever is it, by 28. Right, you have squared each of them instead of taking an absolute value. It's like a standard deviation. You square each of these values instead of absolute value. You square each of them, each of the differences, divide it by their, so take the average of that and then add up all of them and find out the square root again. So this entire thing can be accomplished using a formula called, if you see here, sum, there is xmy2. What this means is you do the summation of xmy. Xmy is x minus y square. Do the squaring of them. So sum xmy2 is nothing but you do the summation of x minus y square, and once the summation is done, then divided by the total value. So without allotting 2 additional columns for that purpose, right, I'll show you in both the ways. Okay, to get a more clarity, what I'll do is I'll insert 2 more columns, residual 4 squared. Similarly, I'll take residual 6 squared. Alright, so let me square all the residuals. So this much square. Fair enough. So all the residuals have been squared here for 4. All the residuals are getting squared here for 6. All the residuals are getting squared here for 6. Now what I am doing is sum of squares of the residuals or probably I call it as average of squares of residuals. I'll put it as 4 period as well as 6 period. which will give me directly the average of the squares of the residuals, giving me 57,000. And I actually take, or not average, deviation, I have to take it as average, right? What has happened? All right, I'll take it as average, so which is coming out to 51,000, and probably I'll take the square root of this, which will give me 226. Whereas in case of 6 period, I'll take the square root of average of all the 6 period residuals. All right, up to here let me take. This is 255. So even this method is saying that 6 period moving average, if I am taking, the error is slightly more compared to a 4 period moving average method. Now the same effect without adding 2 additional columns I and j, what we can get is we can do this using a formula called sum xmy2, which is it subtracts x minus y, which is a residual, squares, and then sums. So this entire aspect is taken care of by sum xmy2. Right? I don't need to even come out with the residuals column, which is G and H columns are also not required. Just observe this. I say sum xmy2, wherein I give one of these inputs as x, which is the share price going with the 4 period average. Right, so I'll take this as x, comma, I'll take this as y. You can do it in either way, x, m, y, because it's a squaring, it hardly matters. Sum xmy2 will do x minus y, which is a residual square. Residual square is done, and the summation of that entire residual squares is done. But after that, I require to find out the average. So for that I'll do the counting, because the total sum I have to divide it by to get the average. So that is where what I'll do is I'll try to find out the total counting of these values. How many values we have included? So that is what is giving me the total average of, so this is what should be this number, average of the squares of the residuals. I have got up to the average of the squares of the residuals, but I require the square root of the entire thing. That is what is I am evaluating. So I could have stopped even without taking the square root, because I can compare it at the square layer also. But the more appropriate aspect is taking the square root. And now what we are seeing is we have got the same answer which we have got after finding out the residual, then squaring it, adding it, averaging it, and finally doing a square root. So sum xmy2 is a very powerful formula from that standpoint. So sum xmy2, here also for the 6 period I'll do the same stuff. So I'll take the original values, which are these. Then 6 period moving average values, which are coming from here. Right, so this gives me x minus y whole squared and the summation of all that entire stuff, and I will divide it by the total counting of how many values are there. So in this case, because we have a 6-month moving average, these are the values which we have considered, and this entire thing I will put under a square root. So this will automatically compute my 6 period moving average. So which period moving average is more appropriate is what is given by my these two tests. Either I can go with the mean absolute deviation method or the least squares method. And again, the least squares method, I can literally compute the average as residual, square it, and then find out the difference. Or I can directly use the formula sum xm y2. Whatever is the mechanism I am using, both of them mean one and the same for me. It's more the interpretation that I need to be comfortable with while I am judging the moving averages. So that's one aspect. But yes, is there any way I can look at the moving averages automatically getting generated without doing this entire aspect? If I go to that data analysis which we have done earlier, that also contains the concept of moving average. Just like the way we have used regression, I can use moving average, which is listed out here. Remember that moving average is a good concept only when I think of considering time series data. That means the data which I have collected should have a time variable in one of its axes. It should have a time component. So only when such kind of thing is present, the moving averages have a meaning. Whereas regression, I need to have some other variable with which I am comparing. In case of moving average, I don't have any other variable for comparing purpose. I am comparing it with respect to time itself. Right, so just a smoothing out of the original data to make sure that the spikes are getting smoothened out and a smooth curve comes out, which can help me in doing my forecastings in a much better and appropriate manner. So using the tool again, go into the data analysis icon, click on the moving average. I select the moving average, say which is the input data I require. Yeah, before I do that, probably let me create one column for moving average. Right, I'll create a column for moving average. So in this, now I can start the process, data analysis, moving average. My input is the share price, so I can start right from here up to the 33rd column. I can say labels are there in the first row because I have selected from B1 to B33, where B1 happens to be a heading. Now the interval I have to decide whether I am going with 4 period or 6 period or any period for that matter. So I'll simply say 4 period here. And where do you want your output to be pasted? So let's say I'll start from here, my outputs to be pasted. Right, I'll say my output, let them be pasted here, and I can also simply put up that I want my chart. Okay, do a quick okay. Moving average, some data will be hidden by the embedded chart because it replaces okay, so when I say okay, all you are seeing here is the first 3 times the data is not available, and from here the average value is coming out. So the simple logic again, to make it eligible for a forecasting purpose, what you do is just change the formula for the previous period, because by default the computation is always with respect to. So in this, instead of B3 to B6, make it as B2 to B5. That itself will suffice and match with your calculations which you have done, because what you are seeing here also is the same formula which you have applied manually. So the moving average tool, yeah, and this is telling you how your moving average is fluctuating. That also we have plotted manually, a 4 period moving average. Here it has plotted as a column chart, whereas we have plotted it as a line chart. Both of them are giving me the same kind of an analysis. So all we have to be more comfortable with is how do I interpret this data and how do I use it for my forecasting purpose. So apart from regression, we should also be comfortable with the usage of moving averages if we have to master the art of forecasting, because a lot of data in whatever backgrounds we talk of, whether it is finance or marketing or HR or technology, in wherever we want a data analysis to be done, there is a lot of focus today on understanding the time series aspects of the data and applying the appropriate time series concepts to the data. Right? You can very well practice on these moving averages. You can take any kind of a time based data, try out 3 period, 4 period, 10 period, different kinds of moving averages. And let me tell you one thing here, the finance world, which is led by the concept called technical analysis, where people take their stock buy and sell decisions based on understanding the past data, uses this concept of moving averages more rigorously, and most of the decisions are taken based on various aspects of statistics along with the moving averages. So understanding of this concept is a very important aspect from this perspective. I hope you are comfortable in terms of understanding this chapter, but a regular practice is definitely required. So please put your effort in terms of understanding the various aspects of moving average, and if you have any further queries on it, you can please feel free to get back to me. All right. So now we'll move further into our next aspect. Are there any further doubts which need to be clarified with respect to moving average? If not, then we can just move forward. All right.